BitTorrent is a pioneering application in the space of peer-to-peer networks. It has some very cool features and to this day it is quite popular. So let's see what it is all about. So prior to BitTorrent, lot of the peer-to-peer systems focused on search. In other words, how to enable efficient search. But BitTorrent totally ignored this question and went totally opposite. In other words, it focused on efficient fetch. Why like this? So in the file sharing community, what is often seen is these flash crowds. Let's say a new game got released, then lot of people will be interested in downloading this particular game. So if we were to plot it, so it will experience lot of popularity, it will shoot up, and then slowly over time this popularity is going to come down. And then some other movie, let's say, got released, again it is going to jump up, and then again slowly the popularity is going to come down. So these are called flash crowds, where at a given point in time there are tons of users wanting to download this particular file. Thereby it is quite important to ensure that all of them are able to fetch these files in an efficient fashion. So what used to happen in the past is, for example, if it were a game release, the company that is releasing the game will have a single source as well as set up multiple mirror sources to facilitate downloading of this game. But as I mentioned, this involves high cost and the servers can become bottlenecks when the client population is very large. So peer-to-peer solutions can help here by leveraging on the resources provided by the peers. So BitTorrent is a peer-to-peer system which basically forms a swarm of peers, and all these peers are interested in the same file. And within the swarm, it facilitates efficient fetching of the file. In other words, each user is going to upload to as well as download from each other simultaneously. So this figure captures what is happening nicely. So you have a large file that you want to share among all these users. All these users are the ones that are interested in this particular file. So this is the swarm that they are forming. So what you do is you divide up these files into chunks. All these different colors are the different chunks. And you are facilitating the file transfer. So let's see this animation in a little bit more detail. So if you see, there are these chunks. So you have passed on this red chunk and green chunk to these two machines. And then these machines are passing on them to some other machines. And slowly, as you can see, these chunks are getting distributed to the different peers. And finally, everyone will have all the chunks. So I will let you see this animation in peace. This is from Wikipedia. So to summarize, to begin with, only this peer had all the chunks. Slowly it started passing these chunks to the other peers, and these other peers are also establishing connections to push these chunks among themselves. So there are two challenges to fetching. One is, as we mentioned before, the churn in the system, that is the peers come and go. They're not going to be constantly be there in the swarm. Another very big problem in the file sharing community is that of freeloaders. So freeloaders are those who download content, but they are not ready to upload, that is share the content with others. That's probably because this traffic is going to consume their bandwidth and they don't want to pay for the cost of that bandwidth. So if everyone is a freeloader that is just downloads and does not upload, then the system is not going to work. So it is very important to ensure that there is no freeloading done as part of the peer-to-peer system. Now with this background, where some rough idea of how BitTorrent is built, go ahead, take some time, 10 minutes, 15 minutes or even 30 minutes to figure out how those four primitives, that is join, publish, search, fetch, are done within the system, and then come back and compare how close you are to the original BitTorrent. So unlike in the previous approaches where we went from join, search, publish, fetch, here we will go in a different order. The reasons will become clear later. So we'll start out with publish. So in BitTorrent system, how does one publish the file that they want to share? So this is how it is done. So you create a torrent file, and this torrent file includes two pieces of information. One is the metadata about the file. So let's see what it is. So metadata basically includes the name of the file, and as I mentioned, a file is divided into pieces, and for each of this piece a hash is calculated, SHA1 hash, and this information is included in the metadata. The piece size is also mentioned. Typically this is 256 kilobytes. That is, you're dividing a file into chunks of 256 kilobytes as well as the length of the file. Apart from this metadata, you also include a URL of a tracker. So what is the role of the tracker? So tracker is nothing but a server that is going to coordinate this file transfer in the swarm. So it's going to keep track of peers in the swarm and help them. These tracker servers, you have both public tracker servers as well as private trackers. In public, anyone can use them. It is a service being provided by someone. Private trackers, on the other hand, are available only by invitation. So you need to be invited to be able to use a private tracker. So once you create a torrent file, what you do is you put this torrent file up on a web server. Again, there are some web servers that provide this service where they list all the torrents that are out there. So you can publish your torrent file on such a web server. So this makes the task of search easy. We'll see that shortly. And not just this, apart from publishing the torrent file on a web server, you also have to ensure that there is a machine that has the entire file that joins the swarm, because there should be someone within the swarm that has the entire file. So you need to ensure that there is an initial seed. So the terminology is seed is someone with the complete file. So to summarize publish, create a torrent, somehow get it up there in the internet. Not just this, ensure that there is a seed that joins the swarm to begin with. Search and join are very simple in BitTorrent. How do you search for a torrent file? This is out of band. In other words, the BitTorrent does not provide a facility for you to search. You can use Google to search for torrent files, or as I mentioned, there are some popular websites that host torrent files. Within them you can type in the keywords and it will give you a list of torrents that match that particular keyword. So you have to somehow get hold of a torrent file. By the way, torrent files can also be shared via email. In other words, you are interested in sharing a file, you could create a torrent file and share it with all your friends via email. That is also feasible. So once a user gets a torrent file, he is going to join the swarm based on the torrent file. As I mentioned, the torrent file has a URL of a tracker. So this user who wants to join a swarm is going to contact the tracker that is listed in the torrent file. And as part of this contact, the user is going to specify the IP address and port information. And amount of upload download is not relevant when you are joining the swarm, but later when you are part of the swarm, you do inform the tracker of how much amount you have uploaded as well as downloaded. This is done periodically. And this tracker is going to provide a list of peers who are currently downloading the same file. So when you join, the tracker is going to tell, see, these are the other peers that are part of the swarm. You can contact them to fetch the file. So BitTorrent uses certain terminology which let's get familiarized with before we proceed further. I mentioned this before. Seed is nothing but a node that has the complete file. There is definitely an initial seeder, but as other people download the files, they can also become seeders. Leech is a node that is still downloading a file. In other words, it does not have the complete file. Now, peers are the ones that run BitTorrent client. Even though I'm talking about a peer-to-peer system, we still call the peer a BitTorrent client because the tracker is viewed as a server. And this peer can be a seed or a leech based on its download status. Again, I mentioned this before, a file is divided into piece. This is typically 256 kilobytes. And each piece is further subdivided into sub-pieces, typically 16 number. So one piece is made up of 16 sub-pieces. So whenever you are requesting from a peer a particular chunk of the file, that request is at a sub-piece level. And just to ensure faster download, you can request up to 5 at any given time. And another thing to keep in mind is a peer can only upload after receiving a complete piece. In other words, if a partial piece it received, it cannot give it to others. It has to wait till it receives the complete piece before it can share it with others. BitTorrent focuses a lot on fetch, so we're going to spend a lot more time on fetch. So as I mentioned, as part of join, a leecher is going to get a list of peers who are downloading the same file. Now you must be wondering, what is there? You have a list, just download the file. Why is fetch such a difficult task? There are quite a few challenges involved, as we will see shortly, but why don't you think of what these challenges are? And also, in order to facilitate fetch, in terms of functionality, there are two things you need to know. What are these two things? The first thing is, which piece should I request? Because as I mentioned, the file is divided into pieces and there are many pieces out there. What piece should I ask from the list of peers? So that is one question you need to answer. So there is a piece selection algorithm, which we will see shortly. Once you have decided that I want to ask for a given piece, who among this list of peers should you ask for? So from whom do I request this particular piece? So that is the next question. And you as a peer are going to get such requests for pieces. Whose request should I accept and who should I deny? So these are some of the questions you need to answer as part of the fetch process. So this aspect of whom to request, whether to accept or deny a request, is taken care of by this choking algorithm. So let's take a break here. During the break, why don't you think on how you would implement these two aspects? Remember the two challenges, one of churn, another of reloaders.